Good day, everyone, especially to our beloved and most handsome instructor, Engineer Renanti Siurang, sir. Today is just a continuation of the Chapter 19 reports, which is the Building Electrical Design Principles. By the way, I'm Richard B. Escobilla, your presenter for today. My topic is all about the system and circuit grounding and occupant protection requirements. Under the system and circuit grounding is the meaning of what is grounding and the grounding requirements. There are three grounding requirements. First is the system grounding, equipment grounding, and the double isolations. And under in the occupant protection requirements is the tamper resistant receptacle requirements, ground fault circuit protection requirements, and the arc fault circuit protection requirements. What is grounding? What is grounding? Grounding is an electrical system. Grounding is required to protect building occupants and electrical equipment. Grounding an electrical system being begins with a ground, an electrode, and direct contact with the earth itself. An earthing system or grounding system connects specific parts of an electric power system with the ground, typically the Earth's conductive surface for safety and functional purposes. The choice of earthing system can affect the safety and electromagnetic compatibility of the installation. This is an example of grounding, path for carrying through soil or floor. The grounding conductor is a continuous conductor that connects the ground to the neutral bus bar and the grounding conductor bus bar in the service equipment or the main panel board. The grounding conductor does not normally carry current. Instead, it links ground to the metal frames or housings, lets and switches. No? Normally na talaga ito no, sa ating pag tayo ay nagpapatayo ng isang building, especially required talaga yung isa na talaga sa ating required yung electrical. Siyempre para tayo ay safety, isa itong yung grounding, isa sa sistema para mapaganda at safety yung ating mga building na gagawin. Kasi grounding of an electrical branch or circuit enables current to take an alternate path back to the overcurrent protection device if an electrical device or appliance short circuits. It requires an additional supplemental wire called the grounding conductor. Nasa building natin, no, syempre meron tayong mga appliances, marami mga refrigerators, televisions. Para maiwasan natin yung mga ground or short circuits, no, kailangan natin maglagay ng grounding conductors. Itong grounding conductors, function niya para, kasi nag-adapt siya ng mga short circuits, siya ang nag-neutralize sa short circuits na mga mangyayari para hindi tayo mag-ground pag tayo ay humawak sa ating sa ating mga appliances katulad nito ng energized cabinet. Hinawakan ng tao kasi siguro ito wala siyang grounding conductor kaya siya na kuryente. Kaya required talaga sa mahalaga yung grounding system sa paggawa natin ng ating mga buildings. Need yung grounding conductor. So what is grounding conductor? Grounding conductor is a continuous conductor that connects the ground to the neutral bus bar and the grounding conductor bus bar and the service equipment or the main panel. Ito na yung sinasabi ko kanina. Na kailangan natin maglagay ng grounding conductor para maiwasan natin yung mga short circuits at Grounding conductor does not normally carry current. Instead, it links ground to the metal frames for housing or appliances and motors, and the metal boxes containing outlets and switches. If needed, the grounding conductor can safely carry current to the ground in the event of a lightning strikes or in cases of damage or defect in circuiting appliances, devices, or equipment. Ito na yung sinasabi ko kanina. Para maiwasan natin yung mga circuits sa appliances at mga devices natin para hindi sila masira pag meron tayong grounding conductor. Next. What are the grounding requirements? In building electrical systems, there are two types of grounding: the system grounding and the equipment grounding. First is the system grounding. System grounding is that part of a building electrical system that provides protection against the electrical shocks, lightning, and fires. System grounding relates to bonding, connecting all building electrical system components at the service entrance equipment at the neutral bus of the main panel board or switchboard. This is an example of pero ito yung isang example pag meron tayong circuit breaker or grounding conductor. Circuit breaker trips no voltage across the ground, height, and grounded conductors. Ito na siya. Pag meron tayong circuit breakers or the grounding conductors, ito na siya. Pag hinawakan mo yung ating mga appliances like refrigerator, pag meron tayong circuit breakers, hindi siya kasi neutralize na yung shocks na pwedeng mangyari pag grounded or yun. Hindi tayo makukuryente. Yan ang advantage pag meron tayong system grounding. What does grounding system must be connected? A grounding system must be connected to some or all of the following elements if available in the building premises. First, an underground metal water pipe is direct contact with the earth for no less than 10 feet or 3 meters. The metal building frame where it is effective grounded. An electrode made of at least 20 feet, 6 meter or 6 meter, if electrically conducted steel reinforcing bars, or bare copper wire no less than that encased in at least 2 inches of concrete that is part of foundations or footing in direct contact with the earth. An electrode made of a steel or iron plate that is at least 1/4 in thick or copper plate that is at least 0.06 inch thick with at least 2 feet squared or 0.2 meters squared of the plate surface in contact with the exterior soil. Next is an electrode made of a grounding ring or bare copper wire no longer than number 2 that encircles the building at a depth no less than 2.5 feet or 0.75 meter below grade. The structural metal frame of a building where the frame is effectively grounded. Number 2 is the equipment grounding. Equipment grounding refers to a grounding conductor or grounding path that connects the non-concurrent carrying metal components of equipments. This may accomplish by installing an additional grounding conductor in all circuits or by permanently bonding or joining metals components such as metallic conduit in a circuit to form a good conductive path. This is an example of equipment grounding conductor. What is equipment grounding? The equipment grounding conductors is bare conductor or a green-colored isolated conductor that connects band, the outlet boxes, metallic raceways, other enclosures, and frames on motors, appliances, and other electrical equipments. Equipment grounding and system grounding electrodes must be bonded. Bonding is accomplished by installing an additional grounding conductor or by permanently joining metals component in a circuit. When joining components to form a good band, specially connections called bonding jumpers may be required to ensure a good connections between the metal components. Bonding jumpers are required in instances when flexible conduit is used. This is an example of system grounding. System grounding and equipment grounding. Siyempre pupunta siya dito, maging system jumper para ma-neutralize ang circuits. Ayan siya. And the third one, what is double isolation? Third one is the double isolation. Double isolations of an appliances or power tool protects the user from electric shock by creating a non-conducting barrier between the user and the electric components inside the appliance or tool. An appliances or tool that is double isolated has two levels of isolating materials between the electrical parts of the appliances and any parts on the outside that can be touched by the user. If the first layer of isolation fails, the second layer provides protection. Double isolation is an isolation that consists of both basic isolations and supplementary isolations. Equipment such as handheld domestic electric drilling machine has the additional safety precautions of double isolations. Ito yung maganda, no, double isolations, kasi dalawa yung ano natin eh. Dalawa yung grounding conductors natin or yung circuit breakers, dalawa. Kasi pag nasira yung isa, meron pa tayong isa para maiwasan pa rin natin yung mga shocks, electric shocks, para hindi tayo makuryente. And my second topic is all about the occupant protection requirements. Occupant protection requirements. Okay. What is tamper-resistant receptacle? Tamper-resistant receptacle or the tamper-resistant outlets are designed to prevent kids from hurting themselves while fidgeting with an outlet. They have two spring-loaded shutters that close the slots when you remove a plug. When you insert a plug, both shutters compress and the slots open again to accept the plug. This is an example of tamper-resistant receptacles or the TTR. TTR requires by the National Electric Code or the NEC since 2008. It is permanently solutions to childhood shocks from tampering with wall outlets. Internal shutters block foreign objects from being inserted into the receptacle. Ito yung itsura niya. Design siya, no, kasi ito ang maganda. Kasi maiwasan natin yung makuryente, lalo na yung mga anak natin. Pag sila hindi sila makapaglaro sa mga saksakan, kasi pag tinanggal mo yung plug dito, masasarado siya kasi meron siyang two springs sa loob na mag-close yung dito butas para hindi delikado pag baka hindi natin alam, baka maglaro yung mga anak natin dito. Siyempre, pasok-pasok dito, makuryente, para maiwasan yung mga ganon. Ni-required ito siya noong 28 ng National Electric Code Sense para maiwasan pagkuryente ng ating mga anak. Diba? What are the tamper-resistant requirements? Tamper-resistant receptacle requirements. The National Electric Code or the NEC has required tamper-resistant receptacles be installed in all 125 voltage or 15 and 20 N electric receptacles in hospital pediatric areas for nearly 3 decades. Recently, the National Electric Code introduced requirements for all 125 voltage or 15 and 20 A electrical receptacles in new residential constructions to be tamper-resistant receptacles. The following ito siya ang isa sa mga required ng National Electric Code na maglagay ng tamper-resistant receptacles. Isa na dito ang daycare centers. Siyempre, daycare centers dito nag-aaral yung mga anak natin. Hindi natin may iwasan na baka paglaruan nila yung mga socket natin, mga receptacles, makuryente, kasunog yung lahat pwedeng mangyari. Children's play areas, syempre dito naglalaro yung mga natin, mga anak. Elementary school, lalo dyan makukulit. Nursery schools, doctor offices and lobbies, retail establishment featuring children's attire or toys, isa rin yan sa na-require ng National Electric Code. Tamper-resistant receptacles should be considered in these areas. All tamper-resistant receptacles must have either the words tamper-resistant or letters TR. Minimum 316 or 5 millimeter high on the device as a clear indication that this is a tamper-resistant receptacles. Meron din parang palatandaan kung ba yung mga receptacles natin is tamper-resistant receptacles, meron silang palatandaan, nilalagyan ng letters na T and R para manotice yung mga tao kung ito ba ay tamper-resistant receptacles. Ganun. What is ground fault circuit protection? A residual current device or residual current circuit breaker is a safety device that quickly breaks an electric circuit to protect equipment and to reduce the risk of serious harm from an ongoing electric shock. Ito isa din siyang example na na circuit breaker kagaya ng doon sa grounding system kanina. Yung para ma-reduce at maiwasan yung mga circuit, mga short circuits, electrical circuits, para maiwasan yung ongoing electric shocks. Ito yung example ng ground fault circuit protection. Ito yun siya ang test and reset para ma-reduce ang risk of serious harm from ongoing electric shocks, lalo na sa mga kabataan. RDC is the name used in the United Kingdom. In the United States and Canada, the terms ground fault circuit interrupter or GFCI, ground fault interrupter or the GFI are appliances leakage current interrupter or the ALCI, also known as the leakage current protection detection interrupter or the LCDI, are used if the RCD device has additional overcurrent protections integrated in the same device. It is referred to as RCBO. Ground fault circuit protection requirements. The National Electric Code introduced requirements for use of GFCI in residence in 1973 when it required GFCI protections of outdoor convenient receptacles within 61.5 feet or 2 meters of grade level. In residential installations, GFCI protections is required at all 125 voltage, single phase 15A and 20A outlets in the locations listed below. The requirements do not apply to to equipment rated at 240 V, baseboard heater, room air conditioners, welding receptacles, or other outlets that are not rated at 125 voltage. The National Electric Code introduced these requirements beginning in the years listed in parentheses. Outdoor convenience outlet within 61 hubs feet or 2 meter of grade level 1973 editions and revised to include all exterior convenience outlets in 1993. The bathroom convenience outlets during 1975, readily accessible convenience outlets in Garage 1978 editions, convenient outlets within 6 feet or 1.8 meter of kitchen sink 1978 editions, and revised to include all kitchen convenience outlets that serve countertops including islands 1996 editions, but not those serving fixed kitchen appliances range and oven, and the refrigerator or freezer. And the refrigerator, convenient outlets in unfinished basement and crawl spaces, exit laundry 1990 editions. Convenience outlets within 6 feet or 1.8 meter of laundry, utility room, or wet bar sink 1993 editions. Other locations require GFCI protections on 120 voltage single phase outlets include commercial kitchens, restroom in commercial, industrial, and in any other non-dwelling type building. Receptacles are with grade level access and at rooftop locations. Commercial garage, elevator pits, agricultural buildings, aircraft hangars, wet locations in healthcare facilities, boat houses, marinas, and boat yards, receptacle outlets on roof except the dwelling units, circuits to resistance, heating units such swimming pool, spa, hot tub, deciding and snow melting heaters, receptacles and lightning outlets near swimming pools, spas, hot tubs, and fountains. Excuse me. What is arc fault circuit protection? Arc fault circuit interrupter. An arc fault circuit interrupter or arc fault detection device is a circuit breaker that breaks the circuit when it detects the electric arcs that are a signature of lost connections in home wiring. Lost connections, which can develop over time, can sometimes become hot enough to ignite house fires. This is an example of arc fault circuit interrupter or the EFCI receptacles. It reduces risk of fires by interrupting power when arc fault occurs. Yan siya. What are arc fault circuit protection requirements? Arc fault circuit protection requirements. The National Electric Code or the NEC requires AFCIS for bedroom circuits in a new residential construction starting in January last 2002. Future editions of the code will likely expand coverage to include the commercial and industrial applications such as use in fire stations, sleeping areas, military housing, hospitals, outpatient clinics, rest homes, retirement homes, and in other locations where extension cords or cord connected equipment may be used and where the general occupancy may be at rest from arc fault. Thank you, and that's all my report for today.